Today's video is going to be a walkthrough on example 3. So as you can see, I have a blank document. I was just going to also show you how to put together an answer to these problems. So I'm going to start here with fixing this little typo. We're going to read about example 3 that involves the Blue Ridge hot tubs that manufactures and sells 3 models of hot tubs: the Aqua Spa, the Hydro Spa, and the Lagoon. And Jack Brown, the owner and manager of the company, needs to decide how many of each type of hot tub to produce during his next product cycle. He buys prefabricated fiberglass hot tub shells to create his hot tubs. The supplier has the capacity to deliver as many hot tub shells as he needs. Jack installs the same type of pump in each model, and he will have 200 pumps available during the production cycle. From a manufacturing standpoint, the main difference between the 3 models of the hot tubs is the labor and tubing. And then we're going to get into all this specific details about how much each type of hot tub requires for labor and tubing. So I'm going to skip over that for right now, and I'm going to get right to, and let me see if I can annotate on here a little bit. So I'm going to get right down to where the question is. We're told he is confident he can sell all he produces. And so really, when we're talking about um, maximizing profit, the question is how many of each model should he produce while remaining within his constraints? So we're in this very last sentence, and I'm once again, oops, I don't know what just happened. But I think I recognize that this should have had a question mark on the end, because it's the question mark that helps us figure out how to set it up. So I'm going to come over here, and I'm just going to have an open Windows document open, and I'm going to just call this example 3. And I'm going to use that question mark to, first of all, help me identify the unknowns. So the unknowns, it says to maximize profit, how many of each model should he produce while remaining within his constraints? So for the unknowns, we're going to have 3 types of spas. So for this, we're going to use 3 variables. So I'm going to say X equals the number of aqua spas, hot tubs, produced in this production product cycle, is what he referred to it as. Okay. And then Y is equal to the same thing. We're just going to copy that over here, but it's now for the Hydrolux hot tubs. So this is the other model. So this is the Hydrolux. And then we have the last variable. So that's what's different and new in this problem. And this is something we would not want to deal with by hand. We would want to deal with it only using Excel. So over here under Aqua Spas, I'm going to put Lagoon for Z. Z is going to be the number of Lagoon hot spas produced in this production cycle. Now the next item that we need to come up with is the LP itself, the linear program itself. And I, as you are aware, believe it is helpful to go and create an intermediate step, what I call pseudomath, which is the table of information. So we're going to go ahead and do that here. Oops. Okay. So I'm going to put in a table. Usually this table involves 4 columns, and usually at least 2 rows, oftentimes 3 rows. This may even have more than that. So here I'm going to put the relevant info, And by the way, you can do all this writing this out by hand. It's just for me, I need to do this, sharing this video, so it's easier for me to do it, typing it out. I actually need one more column here, so I'm going to insert a column to the right, and this is going to be the constraints. All right. So now is when I go back and I'm going to read. Oh, and I think one of the things I also told you guys was I often kind of give myself a little cheat so I don't have, sorry, so I don't get it mixed up. See how easy it is to mix it up. All right, I'm going to say Aquaspa is X, Hydrolux is the Y, and Z is the lagoon spa. And funny that we're talking about spas, I have to clean mine out today. All right, so let's go into the table of information. So now this is when we're going to go back into our word problem here, and I'm going to hopefully find a tool that's going to work for me for annotation. So let's go. Okay, we were reading all about how he gets all as many shells as he wants and all that, yada, yada, yada. So he will have 200 pumps available during the production cycle. And we're told that he installs the same type of pump in each model. So this piece right here, what it's telling me is that I am going to need, for the pumps, I'm going to need one in each model. And when I'm all is said and done, this has got to be less than or equal to 200 pumps. All right, so now I'm going to come back and I'm going to look for the next bit of information. The next bit of information is that from a manufacturing standpoint, the main difference between the three models is the labor and the tubing. So we see here that the the Aquaspa requires 9 hours of labor and 12 feet of tubing. So we got to deal with both of these things, and so I'm going to come over here and put in labor, hours, and tubing, and this is in feet. And it probably is always a good idea to identify the units of measure. If they don't match between the information you get, like for a constraint, like sometimes you can get things in minutes and then you're given a constraint in hours. You have to convert so everything is in the same units. Okay, thankfully this problem is giving us everything in hours. So, okay, here we are on the aqua spa and it's going to be 9 hours of labor. So I'm looking at the green highlight and 12 feet of tubing. Okay, so then I'm going to come back in and I'm going to see what the next thing I read is, and it's the Hydrolux. So the Hydrolux is requires 6 hours of layers and 16 feet of tubing. So I'm now going to come into Hydrolux column and say, okay, I'm going to put in 6 hours of labor and 16 feet of tubing. Okay, one left to go here, and that would be the lagoon. So the lagoon, let me pick a nice color for that one, is going to require 8, so this is the lagoon, and that's our Z, and that's going to require 8 hours of labor and 13 feet of tubing. So coming over to our table, let's put that information in here. So we have 8 hours and 13 feet of tubing. Okay, now we're going to keep reading, and let's go back to the problem and see what comes next. So the next thing that we're going to see is going to be that Jack expects to have 156 labor hours. So that's going to be the most that we can deal with for when it comes to labor. So we're going to make that our constraint for labor. And if anybody wants to know how to type in Word and get these math things, I can, if you're curious and you think that would be helpful for you in life, I can send you some info on that. But like I said, you can do all this part by hand on paper. Um, Kind of weird this 8 formatted different, huh? Okay. Let's go over it now to the tubing. And the tubing constraint is given by the next bit of information in our table. And here it says there's 2,880 feet of tubing. So that's our maximum tubing. We're going to put that in our table. So we're going to put that in here. Oops. 2,880. All right. Now we're going to keep reading and we're going to find out that he is selling these at various prices. The Aquaspa's 2,000 and it costs them $16.50 to produce. Okay, so I'm going to come back over and I'm going to say, kind of scratch my head for a minute and go, okay, well, they're giving me a selling price and a cost. But I know I was supposed to maximize the profit, remember? That was like the very first thing that we knew when we first started this was that we want to maximize profit. So I'm going to go ahead and convert the information. I'm going to go ahead and put the information that I'm given in this intermediate step here, which I'm calling this table of information, like I told you, is the pseudo math. So I'm going to literally sort of not get too confused or off track. I'm going to continue to put this information in my table and see if that helps me get clarity. So I see that we're talking about a selling price, so I'm going to go ahead and put that on here. And the selling price on the Aqua Spa is $2,000. And then we're told that it cost him, so we're talking about the cost per unit. And right, so this was the price per unit. So that's 2,000, and the cost per unit for the Aqua Spa is $16.50. So then the next thing is the selling price of the Hydrolux. And I'll run out of highlighting colors here. The selling price of the Hydrolux is $5,000 and it costs $4,700 to produce. So let's put that in our table. So it sells for $5,000, but it costs a lot more to make. It costs $44,700. Go ahead and format with commas. Keep that consistent here. All right. And then finally, we're going to talk about the lagoon. And so lagoon, I think of green. I'm going to highlight with green. The lagoon is going to sell for 3,900. Oops, 3,900 and cost 3,580. All right, so coming over to our table, let's put this last bit in here. Oops. So this one is 3,900 and it sells for 3,580. Okay, I'm sorry, costs by 3,580. Now notice there's no constraints. The very next sentence that I get to in my word problem says that he is confident he can sell all he produces. So I have to maximize profit. So I need to realize, and this is an important basic concept in our course, that profit per unit is also called margin. And it is the little p minus the little c. So let's go up here. The selling price per unit is also known as the little p, or the individual price, and the cost per unit is also known as the lowercase or little c, right? And that's the difference between those is what we're going to call the margin, and that's what's going to give us our profit. So the profit on this first one is going to be 350 per spa. The second one is 300 per spa, and the last one is going to be 320. Okay, so now this is what we want to maximize. So that those two rows of data, these two rows of data that we had here, trying to get my highlighter back on, sorry. Okay, these two rows of data, the selling price and the cost, are not going to be part of our linear program. They were just info in an intermediate step that enabled us to obtain the coefficients that we're going to need in our objective function. All right, so now that we have this all put together, let's go ahead and write down what that objective function is. So the linear program is an objective function, and it's going to have a verb, maximize or minimize. Okay, so it has to, there's an objective, there's a goal. So in this one is to maximize the profit function, and which is going to equal, I'm going to use the math notation just because it looks a little bit better like a equation. So 350x plus 300y plus 320z. Oops, z. All right. So that's what we want to maximize, and we're going to want that subject to the constraints. So I can go ahead and number these here maybe so we are clear. So the first one is going to come from the pumps. What we have, so oops, that. There we go. All right. So let's go ahead and get our first inequality, and I'm going to be using the pumps. And I'm using the coefficients of 1 on each one of these. So I'm going to come down here and I'm going to say that's 1x. Let me go ahead and do this also in the notation. So x plus y plus z is going to be less than or equal to 200. Okay, so that's my first one. My second one is going to use the labor hours. So now I'm going to be looking at those labor hours. And I can't get this thing to start. Come on. Okay, so now I'm looking at the labor hours. That's going to be my second inequality or constraint. So I'm going to type that in here. That's going to be 9x plus 6y plus 8z is going to be less than or equal to 1,566. Finally, my last of the constraints, and that one is on tubing. So the tubing is right here. Now, I know that I need at least 3 constraints because I have 3 unknowns, and there's a mathematical property that is like sort of like a logic property that we can't solve for 3 unknowns unless we have at least 3 constraints here. So I'm going to go ahead and write my last equation, which is the pink highlighted one. So I see 12x plus 16y plus 13z. And that is less than or equal to 2,880. Okay, now I've taken care of everything that's in the table. So what comes next is sort of common sense, logic, real world thinking. And that is that we are going to have the non-negative constraints because we're not going to be able to make, it doesn't make any sense. It does mathematically, but it doesn't in the real world to make a negative number of spas. So non-negative constraints are in effect here. And that's going to be that x is greater than or equal to 0, that y is greater than or equal to 0, and that z is greater than or equal to 0. Okay, furthermore, we have non-fractional, and that's because we're Jack Brown is not going to make a partial hotspot. Hot, yeah, he's not going to make a hot tub. He's not going to make a partial one. He's going to make a whole one of X. So however many of these will optimize this answer, we have to make sure that it's a whole number. So it's non-fractional. This just means a whole number for values permissible for X, Y, or Z. Okay. All right, so now we've set everything up, and really let me see if I can put this whole thing in here, or if I can find it. Okay, this whole part right here is the, always does this. Let's try to make my default stick, and it won't. Okay, there we go. So that what's in the box, that's the only thing we really needed other than the unknowns. So we didn't need to define the unknowns, right? So put another box around them. So I just want to put boxes around sort of like the minimum that you need to do, because this table of information, sometimes you can do parts of it in your head, but I wanted to make sure I talked through it. I also wanted to tell you that as we saw with example 2, sometimes there's information in the word problem that is a relationship within the two variables that will lead to a constraint, but it doesn't really fit in the table of information very easily. So the table of information is a tool to translate the word problem to a math problem. And for the most part, it will work for us. It just doesn't always work. So that's one situation where when you have that relationship, you just have to kind of write it out to the side and not put it on the table. But it will get included down here in the constraints for the linear program. Okay, well, enough said. Let's switch gears and go ahead and program this in Excel. Oops, I got to get all my annotations. There we go. All right, and I'm also going to shrink up. No, I'm going to shrink up Excel so I can see both on one table. Okay. So I am going to always start with my name in the corner, and I would like you guys to do that. That's kind of what I'm trying to get you to do. And then down here, I'm going to rename um, the worksheet, um, so that this information will show up in my answer report. If you remember in class, I showed you an answer report. Now we're going to come in here and we're going to create our unknowns, our table of information. So let's go ahead and put in what these variables are. We got X, Y, and Z. And over here, I'm going to put the relevant info, and I'm going to basically just try to make this table a little bit more friendly to the eyes. Let's put a border around the whole thing. Let's give the top um, a little bit more of a top looking thing here. I'm just going to give it a little something like this. Maybe I'm going to put borders around that part. Okay, and then I'm going to select all these cells, and I can choose either between A, B, between B, C, anywhere I want to choose. It's going to stretch them all out at the same rate. If I want to make one a little bit bigger by itself, I have to select just that cell. All right, select just that column. All right, so now what I'm going to do is I'm going to come over here and I'm just going to put in what the coefficients are that go in front of the X, the Y, and the Z. And I'm going to just write on the side here that is related to pumps, just to help guide me. So I know that the coefficients for each of these is 1, 1, 1. And I don't like it like that, so I'm going to go ahead and select these 3 columns and hit this formatting center, because I think seeing it in the center helps a little bit. I know down here, I'm going to go ahead and select, I don't have to go that far down, but okay, let's go with 15. I know I'm going to put my constraints in here and they're related to this, so we might as well do it all at once. So I'm going to have my constraints in here. And let's say this one is 200 pumps max possible. All right, so that's basically saying when I come up here and I'm going to get x plus y plus z, the coefficient is 1, 1, 1. All right, the bottom of my table is going to be the amount of each spot. Right? And this part right here, I told you is a good idea. There's nothing magical about highlighting it in yellow. It's just to help your eye see it a little bit better. So let's go ahead and we're going to put that in there. So our constraint that we're going to build, basically it's this equation that we're looking at over here. The x plus y plus z is less than or equal to 200. And we're going to build that first by building the x plus y plus z part here. So I'm going to do it two ways. I'm going to do it the really long pain in the butt way. All right, I'm going to say the coefficient times x plus the coefficient times y plus the coefficient times z. And then I'm going to show you how to do it with a special function Excel has that does that for us and makes it easier to type in. So the first thing is going to be, you're going to take whatever the coefficient is. In this case, it's 1 for pumps. And it's got to be multiplied by this amount of x, which is going to be the number that's going to end up showing up in that box I've just selected. That's highlighted in yellow. And then plus the coefficient for the y, which for x plus y plus z, they're all ones, times however many y or hydrolux spas we end up having, plus the coefficient for the z times the yellow highlighted column, sorry, cell underneath the z. Okay, so now I have this function here. It shows up as 0 because right now there's nothing in this yellow. But if I select up here on the formula bar, I can have the highlights kind of confirm to me I didn't make any typos or pick the wrong cell or did something stupid. All right, so now I come over here and now I'm going to just, as a note to myself, I'm writing in the less than or equal to part. The computer never sees this really as part of the solving the linear program. It's more a notation to myself. And then over here where the constraint goes, I'm going to put 200. All right, so the next thing down is where we're going to be talking about labor. So here, I'm going to put labor. And again, I'm putting these coefficients from labor in here, 9, 6, and 8. So we'll just go 9 tab 6 tab 8. All right. And then when we get down here, we're going to say labor max hours in 1566. So here is where I want to actually write, I'm just making this look a little bit fancier. Okay, in this function right in this cell is where I am going to put in the formula that I see down here under number 2. So I want it to be 9x plus 6y plus 8z. I'll put the less than or equal to part here, and I'll put the 1566 constraint here. Okay? Now, in Excel, you don't put the commas. We certainly use commas to make things more easy to read when we write them out in a problem and anything we're writing in communication, but that comma messes up Excel. So, all right, so what's missing here is this 9x plus 6y plus cz. So the function that will do that for us is called the sum product. It returns the sum of the products of the corresponding ranges or arrays. So we're going to come up here and we're going to say, okay, we're going to take each one of these coefficients and we're going to multiply it by each one of these numbers and we're going to add those together. So that right there is going to do the mathematically the same as if I typed it out the way I did in the first one. Okay, I just think it's a little bit easier to deal with that way. All right, and finally, the next thing I'm going to be looking at now is the tubing. So the tubing is this constraint corresponds to the equation number 3 down below. So I'm going to put that into our table, and that is tubing. So tubing is 12, tab 16, tab 13. Okay. And I'm going to come in here, max tubing, it is 2880 feet. Okay, so we're just going to come in and I'm going to also use some product. Once you get to 3 or more unknowns, really some product is your friend. So I'm going to do coefficients, the 12, 16, and 13, and the amounts of x, y, and z. And those are going to get multiplied together. We know that that's eventually going to need to be less than or equal to 2880. So now the only part that we have skipped over is this, see if I can highlight it. No, there we go. Is the objective function we want to maximize. So I'm going to go ahead and write that in here in between. So let's write the objective function. And we want to maximize it. And here's where we're going to actually use that sum product, but we're missing the amount of profit from each one. So now we got to put this profit into the table. So profit. I have an extra row on my table, and that's no big deal. In fact, what I could do maybe is just put the profit, leave a space in between the constraints and the profit. So now I'm typing in the margin. So it's a difference between the selling price and the cost per spot. So we got 350, 300, and 320 is what I'm reading off of the table over here that we want to maximize. So that's the function that's going into this cell right here, C12. Or I could pick any cell I wanted. I'm just recommending this kind of layout. It's nice, compact layout that's easy to follow. So in this objective function row, I'm putting the function, which is this profit function, but I dropped the P equals part. I'm just going to write the 350x plus 300y plus 320z using the sum product. This equals sum product, and we want those coefficients for the first vector or array, and we're going to multiply that by whatever is going to end up being in here for x, y, and z. Okay. Now we're all set to run our linear program and run the solver. So for that, I'm going to actually select the cell that has the objective function. And that's just to save me a little bit of time. There's nothing wrong if you don't do that. But that just saves me time because when I go into my data tab and come over to my solver, what I'll end up getting is that the very first thing it wants is the location of the objective function. So you see right now, it's already selected that for me. Now the next thing down in this GUI, which is a graphic user interface, it's just a little pop-up box that we're going to fill in, is we're going to choose whether we want a max, a min, or some other value. Yes, it's possible to get other values, but we're going to focus on max and mins for optimization. So we do want to maximize the profit. And then it says by changing variable cells. So this is where it's going to put in the variables that could, values that could change. So I selected all three of the cells underneath the X, Y, and Z columns. And that's popped that right in there. So now I'm going to come down here to subject to the constraints. And I'm just going to make sure we're clear that I am following this linear program that's in this box. And what I'm going to end up having is an Excel version of all of this. And I've set things up here in this worksheet so I can easily pop it into this solver. So I'm going to add in here this function. It already defaulted to less than or equal to, and I want that less than or equal to 200. Now I'm going to add another constraint, which is this function for labor, and it's also less than or equal to, and it's less than or equal to this cell, 1566. Now I'm going to add another constraint, which is this max tubing, and that goes there. It's less than or equal to, and its constraint is 2,880. And I just realized I did not type in here the non-negative constraints, so I'll just say OK. And I'm going to hit close for right now because I need to add in those non-negative constraints back in here. So let's go in here and we'll say non-negative and non-fractional. So you want to have everything, and if it overlaps like that, it's because it's formatted to be in the middle and that messes it up. So I'm going to make that one left justified. Okay. All right, so let's go back to solver and put that in. All right, so we got everything in here. We're coming through these three constraints, and now we need to add the non-fractional ones. So to do this with the cell reference, this is going to be a little different because we're actually going to pick a range of cells, these 3 cells. And what we're basically going to tell Excel is, okay, you go ahead and solve this, however is the optimal solution, but here's the rules. Whatever goes in here has to be an integer, right? So we're doing that, and we're done now. We put in these constraints, and because the non-negative constraints are so common, Excel sort of sets it up already for you as an automatically by default checkbox on this little choice here. Now, the next thing we want to do that's important is come down here and select the solving method. We're doing linear programming, so solver can do more things, but we're going to come here and we're going to select the simplex LP, and then we hit solve. Now, when you get the answer, sometimes Excel on harder, longer, more difficult problems may take a little longer. If you notice, there was a little bell that there was a ding, and that's because it was very quick to find the solution. I can move that over and you can see that I found that my objective function is 66,100 and the amount of each spa is 122 aqua spas, 78 hydrolux, and no lagoons. Now to continue this process of getting an answer out of this, I'm going to click this answer on the reports and then I hit OK. And then down here below on the worksheet, we got a new tab. And we can go over here and we can see that it gives us basically the output. It has everything we put in. And it will give us automatically the amount of each spa. It figured out to call that. Each of these things, it did all of this for us. Okay. So what we're going to do now is assemble the answer. So I'm going to come back over here and I'm in my Word document and I'm going to come to the bottom of where I had the LP. And the first thing I want to do is I'm going to do a screenshot of the worksheet. So in Windows, you hit the Windows Shift S, and that gives you the windows for the snip program. So I'm going to just do a screenshot of this. And I'm going to come back over here, and I'm going to add it in here by hitting Control V. That was added in. Next thing I want to do is I'm going to put a version of this that shows the formulas that basically shows me that you did actually program this and didn't just copy it. So to do that, you're going to go to Formulas and you're going to click Show Formulas. And this tends to make it really wide, and you don't need it that wide. So let's select all of these columns. So selected A, I come over to D, I hit Shift click, and now I'm going to come to the space between the columns, and I'm going to shrink this up a little bit. Maybe I need to make it just a little bit bigger so we can see what's in there, but they don't need to go crazy wide columns it'll default to. But all right, once we got this, we're going to also take a screenshot of this page. So it's the same page, it's just showing the formulas. And we're going to come back over to our Word document. If I can get over there. All right, so I'm going to come over here and I'm going to hit Control V or paste. And I get now the same worksheet but showing formulas. All right. Then I'm going to come over to the answer report and I'm going to do the same thing on the answer report. I'm going to take a screenshot of that. So I get this screenshot. Come over to the Word document, and I'm going to paste that screenshot in there. Okay, so finally, when all is said and done, I'm going to put my answer. And remember, step 5 of the method of corners is that you provide the answer in a sentence in your own words. So in this case, I would say, to maximize profit, I believe his name was Jack Brown. Jack Brown? Yeah, Jack Brown. To maximize profit, Jack Brown should make 122 aqua spas and 78 hydro lux spas. He should stop making any lagoon spas. Okay, the optimization showed us that the maximum profit is obtained when there's 0, Z, and Z, if you recall, is the number of lagoon spas. Okay, then we would definitely always want to put the value of the objective function. Doing this will enable a maximum profit of $66,100 for this product cycle. Okay, and that's how you do one of these 3 variable linear programming problems from start to finish.